a simple hard-pressed student. I've got a field of interest that overlaps with the workshop theme, but it's certainly not identical, and I most emphatically don't claim any level of expertise with implants per se. I've just got some observations that are intersect with that field. Incidentally, if the presentation appears to be not all that well rehearsed, could be there's something that it hasn't been all that well rehearsed. So, I'm going to make an introduction to my own field of interest, work through from the bottom up, so to speak, and please bear with me, I will actually get to the topic of the workshop towards the end. So I'll go through my own field of interest, comment on how it's relevant, propose a few questions, and then hand over to the ones who are actually qualified to speak on this topic. Starting with a rather well-worn quote that Katina's heard before a couple of times, or three. Senator John Glenn, talking at his retirement speech, somebody asked him what was he thinking when he was sitting in the Mercury capsule listening to the countdown, and his straight off the cuff quote was, well, the same as you'd be thinking if you were sitting on top of all that amount of explosive and several million parts, all made by the lowest bidder on a government contract. And of course, when we look a wee bit further forward from Apollo 13, and very sadly with the Challenger in Columbia, we see examples of cases where one thing goes wrong and there's a catastrophic result. But that's all in the fairly high-tech realm, and it's somewhat different in the sense of the practicality of control. What we have got now is an estimated, I think it's about 50% or more of the world's population living in cities, predicted to go up to 75 by 2050, I think. And there's some social phenomena that come out of that. One that I've noticed is, not the only one by a long shot, is the awareness of the dislocation of an individual from the sources of things that are actually essential to their lives. We see it at some quite mundane levels with self-sufficiency movements. We see it at some perhaps rather verging on the bizarre level with the prepper movement in the States. They all have, in my view, they have a common origin, and that's the awareness, whether it's well articulated or not, that we're actually dependent for our lifestyle on a whole lot of things which are the products of long and complex systems and which we don't have much control over. So okay, that's a rather too broad build-up perhaps. I want to bring it a bit closer to home, closer to my own field of interest. My interest is in developing that concept of an individual's vulnerability to technology systems, and particularly when those technology systems supply goods or services that people really rely on. What I've done in my study, I've selected a small, hopefully reasonably representative group of essentials, and they've included, they really are quite broad. They've included things like fresh food, example, local petrol supply, example, sewage disposal, and a couple of other examples. So they really are quite broad, but they're all characterised by the fact that if they became unavailable, they really do have a significant effect on the lifestyle of the people who are consuming them. Studying these examples, I've tried to answer the question, how can I quantify, how can I describe the vulnerability that actually flows through from those systems to the consumer? And I've come to a couple of conclusions that I wanted to bring to the workshop. Two that I think are relevant to the workshop. First is that when we talk about risks and probabilities, traditionally we generally, not always, but generally talk about probabilities. There's an assumption of a statistical variability, things that might happen once in 100 years, things that might happen once in 1,000 years. But I feel that that's valuable. It's not the only way to look at hazards, and I actually can't see well enough to see the age of the participants, but anyone who remember the the Captain Crunch and the phone freaks of the 70s will remember the story that the cereal packets contained a little whistle, and the little whistle just happened to have the tones that corresponded with AT&T's in-band signalling. You blew the whistle and you got a free toll call. The relevance here is that there was nothing statistical about the probability of a free toll call. If somebody blew the thing 20 times a day, they got 20 calls, and if they blew it 100 times a day, they got 100 calls. It was somewhat qualitatively different from a random occurrence. The second observation, so that's one of two, the second observation is that if you're talking about a technological system that's supplying something, whether it's a goods or a services, that system will have a set of weaknesses. It'll have a set of things which, if they fail in the processes or streams, will cause the final output to fail. And those list of weaknesses are really quite critical. Every time there is a weakness, every time there is a process or a stream that can cause failure, then by definition there's going to be some hazards that are associated with that weakness. And if you haven't actually looked at those weaknesses, or you haven't managed to enumerate or articulate those weaknesses, then almost by definition there are a set of hazards that are actually not being taken account of. So I brought those two concepts together, and what I've proposed is that the word exposure, which is often defined rather loosely, or even if it's intuitively understood, but I've proposed that you can actually apply a values, or a set of values to exposure, linked to the configuration of the technological system, and basically to the number of single, double, triple things which can go wrong, which will cause a failure. So actually getting a value out that you put on that exposure. So, all right, I've spent perhaps rather a long time leading up to where this is relevant to the workshop topic. If we start talking about implants, particularly brain implants, and I need to say again, I know very little about brain implants at all, but surely they must be the sort of quintessence of a service that's supplied to an individual. What can be possibly more essential than something that's operating inside the skull? Let's imagine that that service, whatever it is that's being provided within the brain, has a technological system in the implant, and that system has item A that is fed by item B that's fed by item C, or whatever down the line. It has a certain number of inputs and they're all essential. If we, though, introduce a design feature, and somewhere in that line we say, oh, we could actually introduce an output from elsewhere, very important, very useful, but that input that came from elsewhere, perhaps we'll call it E, in itself was dependent on F, G, H and I, then all of a sudden that exposure value, that A plus B plus C that you originally had on the service, is added to by the contributory system. And I think that's the point that I want to, the real point that I want to bring to the workshop, that if we are talking about a complex system with a single point of supply, a set of dependencies, if we introduce a contributory system, we add to the exposure by all the level of exposure of that contributory system. And it seems to me if we're talking about implants, then that's front and centre. The flip side, of course, is that it's possible to look at what the dependencies are and say, well, okay, how can we actually reduce them? If we enumerate them, then almost by definition, you've got the means, at least in principle, to reduce them. So look, that's really all I want to contribute. I'm very interested to hear the other speakers.